Hi everyone, welcome to my new video in my Mathematics Essentials series. My previous video was about how to find the sine and the cosine of the special angles, and this video is about how to find the sine and the cosine of any multiple of the special angles. Okay, now recall that when we are finding the sine or the cosine of any of the special angles, actually I'll write down what the special angles are to remind you. So we have 0 radians, pi over 6 radians, which is 30 degrees, pi over 4 radians, which is 45 degrees, pi over 3 radians, which is 60 degrees, pi over 2 radians, which is 90 degrees, and pi, which is 180 degrees, typically doesn't get a mention among the special angles, but that's okay. Okay, whenever we are trying to find the sine and the cosine of one of these special angles, we need to defer to one of these special triangles, so it pays to memorize them, or at least that's the easiest way to do it. Okay, you could memorize the unit circle, but that's more difficult. So if we want to find the sine and the cosine of some multiple of the special angle, assuming that multiple doesn't simplify to one of these special angles, so for instance, you might have 2 pi over 4, well that just simplifies to pi over 2, and that just is one of the special angles, okay? So what I'm really concerned with is multiples of these special angles that are in lowest terms. So for instance, 3 pi over 4, okay? If you wanted to find the sine or the cosine of 3 pi over 4, all this comes down to doing is finding the sine or the cosine of just the special angle pi over 4, and then deferring to the appropriate special triangle, which would be this one, okay? Then you would get an answer, and that would be very similar or perhaps identical to your answer for the sine or the cosine of 3 pi over 4. You just don't know whether it's going to be positive or negative. Maybe you do if you can just visualize it all in your head, but it's pretty easy to defer to a cast diagram. Okay, then you find out which quadrant of the cast diagram your angle is in, 3 pi over 4, and it tells you whether your answer is going to be the positive or the negative of your answer to what you got for the sine or the cosine of pi on 4. Okay, so all you are doing over and above what you do when you find the sine or the cosine of one of the special angles, okay, if you're trying to find the sine or the cosine of one of the multiples, the only extra thing you do is consult a cast diagram to determine whether your answer is positive or negative. So I've written out these examples. Okay, so for us to find the cosine of 5 pi on 3, then we first concern ourselves with the cosine of the special angle pi over 3. And then we consult the appropriate special triangle, okay, which has a side length of 1. This one is 2, and the square root of 3. This angle is pi over 6. This angle is pi over 3. Okay, and we can basically read off the answer. Cosine of some angle is adjacent over hypotenuse. So the cosine of pi over 3 is a half. Now, either positive a half or negative a half is going to be our answer to the cosine of 5 pi on 3. Okay, one of these, but not both. So in other words, this isn't one of those mathematical problems that can have two solutions. Okay, it will be either this one or this one, but not both of them. Okay, and to determine which it is, we just draw a cast diagram. And we figure out which quadrant of the cast diagram an angle of 5 pi on 3 would be in. Okay, and to do that, it's handy to use an angle of 2 pi, so that would be here, all right, as a reference point, and sometimes an angle of pi. You won't use both of them, you'll pick the easier one. Okay, so you'll know that your angle is closer to one of these two angles, and you'll figure out from using either of these as a starting point which quadrant your angle falls in. So for example, with our angle 5 pi on 3, well, our angle is almost 6 pi on 3, but that is just 2 pi, or 360 degrees. So 6 pi on 3 would correspond to going all the way around the unit circle, a whole revolution. But we haven't gone 6 pi on 3, we've stopped just short at 5 pi on 3, okay? 5 pi on 3 is just pi on 3 short of 6 pi on 3. So it puts us in the cosine positive quadrant, which means our answer to the cosine of 5 pi on 3 is just positive 1/2. Okay? You don't have to write this kind of thing out. Okay? I'm just putting my thoughts down on a page, so it's easier to follow along. You can't read my mind. That's why I'm doing it. Okay? Suppose we're asked to find the sine of 5 pi on 4. Okay, well, we concern ourselves initially with just the sine of the special angle pi on 4. We draw the relevant triangle. I'll use the inked shape function. Okay, we draw the appropriate special triangle that has an angle of pi on 4. Okay, special triangle with an angle of pi on 4 actually has two angles of pi on 4 and two side lengths of length 1, which makes sense. Two angles of the same size would span two side lengths of the same length, and the hypotenuse has a length of the square root of 2. So we can read off the sine of pi on 4, and that would be opposite over hypotenuse, 1 over the square root of 2. Now we just need to consult a cast diagram to determine what our answer is to the sine of 5 pi on 4. And to do that, we figure out which quadrant an angle of 5 pi on 4 is in. Now 5 pi on 4, well, that's almost 6 pi on 4. Okay, you don't have to use 2 pi or pi as a reference point. Okay, you can sometimes use pi on 2 or 3 pi on 2 as a reference point. So 6 pi on 4 is equal to 3 pi on 2. Okay, so that is 3 pi on 2 there, or 270 degrees. Okay, well, 5 pi on 4 is almost 6 pi on 4. So we have almost gone 270 degrees, or 3 pi on 2 radians around the unit circle, but not quite. Okay, we've stopped short of 6 pi on 4, which puts us in the tan positive quadrant. So our answer is going to be negative 1 over the square root of 2, because sine is negative in the tan positive quadrant. Okay, that's that example done. What about the tan of pi? Well, there isn't a special triangle we can draw for the tangent of pi, and the pi is not, one of the special angles, although you work with pi a lot. But nonetheless, you know that the tangent of pi is defined as the sine of pi over the cosine of pi. And perhaps you can imagine it in your head, or if not, eventually you'll be able to when you are really familiar with the unit circle and the special angles and the special triangles. But otherwise you can just label what these points are, or just the one that you are concerned with, which would be an angle of pi. So this point here would have coordinates x equals -1, so that's the x component, and y equals 0, that would be the y component. So the tangent of pi, which comes down to the sine of pi over the cosine of pi, would just equal 0 over -1, which of course is 0. So the tangent of pi is 0. Okay, if ever you need to just draw a unit circle, you can draw something quick like this and just label what these points would be. And that helps you find, the sine, the cosine, and therefore the tangent of, any multiple of pi on 2, really. And this one would be 0, -1. Okay, moving on, let's do the tangent of 3 pi on 4. Okay, well, I draw the appropriate special triangle after my surface pen is being buggy. There we go. After concerning myself with the tangent of pi on 4, which is going to be equal to sine pi on 4 over the cosine of pi on 4. You may remember that the sine of pi on 4 and the cosine of pi on 4 are equal to each other, so you might already know that this equals 1. But if in doubt, you can draw a unit circle. Sorry, not a unit circle, the relevant special triangle. Okay, it's a right angled triangle with these side lengths and these angles. And you can see that both the sine and the cosine of pi on 4 is 1 over root 2. Okay, so you would just have the same thing over the same thing, which of course is 1. So the tangent of 3 the tangent of pi on 4 is 1. So to determine what the tangent of 3 pi on 4 is, all we need to do is draw a cast diagram and see which quadrant an angle of 3 pi over 4 resides in. Now 3 pi on 4 is almost 4 pi on 4, which is just pi. So 3 pi on 4 is almost 180 degrees or pi radians around the unit circle, but not quite. So it would place us in this quadrant. Okay, and when I draw these angles on the cast diagram, I don't really care how accurately I'm drawing them, because in the right quadrant is good enough for our purposes. When we draw the cast diagram, we're only concerned with determining whether our answer is going to be positive or negative, and to determine that, we only need to place our angle in the correct quadrant of the cast diagram. So I'm not too concerned if, for instance, pi on 3 is, really up here somewhere, and I draw it like that. Okay, that's fine. Okay, I just want to get it in the right quadrant. All right, so I can see that 3 pi on 4 resides in the sine positive quadrant, so tan must be negative in that quadrant, and my answer must be -1. Okay, one more example before I wrap things up. Okay, let's do the cosine of 11 pi on 6. So first, I just calculate the cosine of the special angle pi on 6. I draw the appropriate special triangle. Okay, with the corresponding angles. All right, and then I can just read off the cosine of pi on 6, and that is √3/2. And then I draw a cast diagram to determine whether my answer to the cosine of 11 pi on 6 is going to be positive or negative. Okay, now 11 pi on 6 is almost 12 pi on 6, which is just 2 pi. So that would be a full revolution around the unit circle. Okay, but 11 pi on 6 is not quite that far. It stops pi on 6 short of 12 pi on 6, which is 2 pi. So we would be in this quadrant. And in that quadrant, cosine is positive, so I know that my answer is going to be positive √3/2. Okay, so that pretty much is how you calculate the sine and the cosine of multiples of our special angles. You just find the sine or the cosine of the special angle, okay, the appropriate special angle. You draw the appropriate special triangle, you get an answer, and then for the answer to your actual problem, you need to know whether it's positive or negative, the answer to the simple problem, and to do that, you consult a cast diagram. Okay, so if you found this video helpful, give it a like. Feel free to share the video. If you have a question, post it in the comments and I'll get back to you. And if you would like a notification when I release a new video, subscribe to my channel. Until the next video, bye for now.